Welcome to the Thunderdome called 3.7. We're going to be doing this thing called completing the square, and you're going to love it. Let's jump into it. All right, before we get too deep into it, we need to do a quick review of factoring. So we're looking at the trinomial form, and there's a specific pattern of factoring where if we take half of b and square it, that's going to equal a times c. And in that specific case, we have a pattern. It's called the perfect square trinomials. But let's do some examples and hopefully you'll remember a little bit. You don't necessarily need to recognize that it's a perfect square trinomial normally, but in this entire section, everything that we factor is going to be a perfect square trinomial. But if you remember factoring from Algebra 1, we would, we would look at this number and we would find two numbers multiplied together that we then take those two numbers and then add them together to get that number. So that's our like normal trinomial factoring. So it turns out if we take 4 times 4, 4 times 4 is 16. But then if we add them together, we're going to get 8. So in this case, if we were to factor it, we would get x plus 4 times x plus 4, which is also equal to x plus 4 squared. So that is the perfect square trinomial, when we have the specific situation where these two are the same and we can just square it. Hopefully you recognize that this might be used in a vertex form like we talked about in the last lesson. So that's kind of where we're going. But let's do a couple more examples. So we've got 1 right here. The only factors of 1 are 1, so 1 times 1 is 1. And then 1 plus 1 is 2. So we do in fact have a perfect square trinomial. So we can write a plus 1 squared. Now, if you know that it's a perfect square trinomial, like hint, hint, if you intentionally made it, like we will do later on, there's a couple of patterns that you should recognize. You can either take half of that number, and that's the number that's going to go inside, and you just square the whole thing, or you take the square root of that number, and again, either one of those will work. So if we move over here, using that pattern, so okay, we got some negative signs here, that's fine. You just throw them in your middle, and then it all works out. So I'm telling you right now, these next two are a perfect square trinomial. Given that information, you can just look at this number, square root it, or look at this number and have it. In fact, it might be better to do this number because you'll include the sign. So if we take half of 18, what do we get? 9. So our perfect square trinomial is going to be m minus 9, and we're going to square it. So I just took half of this number and put it right there, and then square it. And then if you wanted to like kind of do a proof, you could then square this out by multiplying it all out, and whenever you combine like terms, you will get this thing back again. So last review example, we've got, I'm going to look at whatever half of this number is. So I'm going to do p minus 5 quantity squared is how we would say that. And that is doing perfect squared trinomials. So we are going to be factoring just a little bit in this section, but they're all going to be perfect square trinomials. So I wanted to remind you of this pattern. Hopefully you learned once or twice. All right, now that you remember perfect square trinomials, here's the point of the lesson. We learned about this thing called standard form for quadratic equations. We learned about this thing called vertex form in quadratic equations. So how do you convert between the two of them? So remember in lines, it was just simple algebra. You had a y and an x and a number, and you just kind of algebraically move them around until you have y equals mx plus b. For quadratics, it's a little bit more complicated. We have to use this thing called completing the square. So completing the square can be challenging for for some, but I'm going to tell you right now, it's going to come back and haunt you at least 3 or 4 more times in this class. So learn it now, save yourself the trouble later on. At least learn it, maybe later on in the class you can be reminded. But either way, it's called completing the square. So here we go. So step 1, you're going to group the x squared and the x number together. You're just going to put them in parentheses and everything else just push out over here. So step 2, you're going to factor. If there is an a right there, you're going to factor that out because you don't want an a with that x squared. We want that thing to be just by itself. Most of the time this a is going to be 1. You don't have to really deal with it. But in the off case that it's not, we got to do with it. So then we complete the square. So this is kind of the tough part right here. I'm going to highlight it because this is where I'm going to lose somebody. So when we complete the square, we take half of b, we square it, and this is the new c. So we're going to add this to what we had up here, and this is going to be a perfect square trinomial. But in order to add something to the equation, because we only have one side of the equal sign to work with, because we're still dealing with functions, if we add something, we then have to subtract it as well. So that's what this part is for right here. So then we subtract that value from the end of the equation, and then from there we factor and simplify the end of the equation, and then what we have left over is the equation. Right? Clear as mud. Let's do some examples. All right, here we are at number 2. We skipped number 1 because it's a terrible example, so forget that one. Okay, so I'm just going to follow the steps just like it is above in the notes. So step 1, we're going to group our x squared and our x together. So I'm just going to put parentheses around that. So now we've got our x and our x squared together, and this is just going to move out here. We're not even going to bother with it right now. And the reason we're doing this is because we want to strategically add a perfect square number so that we can factor this in the way that we want to do it. So this is just not the right number. So we're just going to change it later on to the right number using legal, valid mathematical methods. Anyway, step 1, we group x squared and x together. So step 2 is we would factor the number out of our x squared. We don't have one there, so we're good. Step 3, we're going to complete the square. So remember, it says by taking half of b and squaring it. So this is our b. We're going to take half of that, so -8 divided by 2, and then we're going to square it. So all of that equals 8 divided by 2 is 4. 4 squared is 8, 16. So 16 is our magic value. I call it a magic value because we're kind of pulling it out of midair, and then we're going to add and subtract it. So 16 is our number. So now we are going to add it into our equation. So if I rewrite this, we've got x squared minus 8x. I'm going to add my 16 right there. And then we've got our 18. And then because we added that 16, so step 4 is we have to subtract it from the end of the equation. So I hope that makes sense. In order to add this and not change the equation, we have to subtract it later on. Okay? So from there, we can put our parentheses back in. And now we can simplify and factor. So this part factors into, it's a perfect square trinomial. So now we've got x, minus 4 quantity squared. And then we just need to combine these two terms. So 18 minus 16, 6, 7, 8, plus 2. So now we have our function in vertex form. We'll write our little f of x there. And we can look at that and say, oh, our vertex is 4, 2. No problem. Okay, so our next curveball is if we have a value right here, that's our a value. This is going to make it one extra step that we have to make sure that we pay attention to. But we'll still follow the steps. So step 1, we're going to group my first two together. So now we have to factor that negative sign out. So now we are looking at a negative sign on the outside. We've got x squared minus 6x, because I took a negative sign out of both of them, minus 5. And again, we're just leaving that 5 off to the side. We don't really want it. We're going to change it no matter what. So now we need to figure out our magic value. The differences are the completing the square. So we're going to look at this number. We're going to take half of it and square it. So negative 6 divided by 2 squared. By the way, you will see that I forget this negative sign a lot because in my math brain, I know that it's going to get squared, so that negative sign is always going to go away. But I still try to put it in there so that you guys can follow along. So negative 6 divided by 2 is 3. 3 squared is 9. So our number that we're going to add is 9. So here we go. We've got x squared. And now here's where it gets a little weird. So I want to add that 9 inside of the parentheses, because that's actually where I want it, which also means I'm going to have to subtract that 9 inside of the parentheses to make sure that I don't mess up my parentheses later on. But the problem is I don't want that negative 9 inside the parentheses. I can't factor it with that negative 9 inside the parentheses. So this guy has got to come out. The way you get it out of the parentheses is you have to take it and multiply it by whatever number that is, and then it can come out. So if I were to do that, I'm going to take my negative 9 multiplied by the negative 1 on the outside, and it's going to turn into a positive 9 on the outside. So now we've got negative on the outside, x squared minus 6x plus 9, and then that negative 9 got multiplied by that negative sign and turned into a positive 9 on the outside of the parentheses, and then we have the negative 5 left over. Okay, so now we factor and simplify, and then we should be good to go. So we're going to factor this guy. That negative sign stays on the outside. So I'm going to look at half of negative 6. So we're going to have x minus 3 squared plus 9 minus 5. So we're going to have 4 left over. And that is our vertex form. From that, I can look at and find my vertex, which is 3, 4. And I can look at that and go, oh, that graph is facing down because we got a negative sign there. So the vertex form just gives us a lot more information. Practice makes perfect. Let's do another. So I'm looking at number 4. And again, we've got that a value right here that kind of makes things a little bit more complicated, but it's good practice for us. So we're going to group these two together. And I see that 2 is there, so we're going to factor that 2 out. So now we are dealing with 2x squared minus 6, because that 2 has to come out of the 12x as well. And then plus 13, plus 13 on the outside. So now we're looking at how to complete the square. We basically just did steps 1 and 2 together. So now we need to figure out what number we need to add and subtract. What is the magic number that we're going to use to complete the square? We're looking at this. We're going to take half of it and square it. So half of 6 is negative 3. Yeah. And then we're going to square it. So we've got 9. So now we want that inside of the parenthesis. So we've got 2x squared minus 6x So we're going to add 9, but in order to add 9 and not change the problem, we have to subtract 9, and we're going to leave all of that inside of the parenthesis right now. But as mentioned, we don't want this negative 9 inside the parenthesis. So in order to take it out, we need to take this negative 9, multiply it by this 2, and then it can come out to the end of the equation. So that's what we will do. So we're going to take negative 9 multiplied by the 2, and then we're going to add it to the end. So that's going to be, so we will have 2x squared minus 6x plus 9. And then negative 9 times 2 is negative 18 plus 13. So we don't want to drop our 13 either. So then we factor. So then we got 2. When I factor, I'm looking at whatever half of that number is. So that's x minus 3 squared. And then negative 18 plus 13, 3, 4, 5, 6, 7, 8. It's 5. Minus 5 left over. And there it is. We're in vertex form. So from there, my vertex is going to be 3, negative 5. And there's actually a vertical stretch by 2. Next example. So I'm looking at number 5. So step 1, we are going to group both of these together. And I can already tell you that because this is not an even number, this is going to get a little crazy. But that's okay. Fractions aren't that scary. Okay, so we've grouped those together, and we don't need to factor anything out, so that's good. So we're at step 3 already, but we need to figure out our magic number, the thing that we're going to add and subtract. So we're going to look at negative 3. We're going to do negative 3 divided by 2, and then we're going to square that. So that's a fraction. We're going to leave it as a fraction. It's going to turn into 9 over 4. So yes, fractions are kind of harder to work with, but we do the exact same process. So don't get freaked out because there's fractions. So we are going to take that 9 over 4. We're going to add it to the inside. So that means we're going to have x squared minus 3x plus 9 over 4. Since we added that 9 over 4, we also have to subtract that 9 over 4. And we're going to keep all of that inside of the parentheses. And then we have that minus 2 left over. So again, we don't want this 9 over 4, this negative 9 over 4 inside here. So we're going to have to multiply it by this coefficient out here, which is just 1. It's an implied 1. Which makes life a lot easier, so nothing changes about the negative 9 over 4. So our new equation looks like x squared minus 3x plus 9 over 4. And then we've got minus 9 over 4 minus 2, and I'm automatically just going to make that as a fraction because we're going to have to do that no matter what. Okay, so I'm going to do kind of 2 steps here this next time. So we're going to factor this guy. So that's going to be x minus 3 over 2. So I just took half of 3. That's where that number came from. We're going to square that because, again, we just factored that blue part right there. And now we got to combine these two like terms. So we're adding fractions, kind of the rule of negative, but whatever. So we got negative 9 over 4 minus 4 over 2. So I just multiplied this by 2 over 2, which is going to equal 9, 10, 11, 12, 13, negative 13 over 2. So that means that's going to go right there. So we're completing the square. And again, yes, there's fractions. But if you follow the process, then the fractions aren't that bad. But it's just a process, and you got to kind of follow it to the end. Fractions make things a little bit harder, but it's not terrible, right? Number 7 is another fraction one, so might as well go through that one with you. So we're going to follow the steps. Step one, we are going to group these two together. There is nothing on the outside, so that's probably a little convenient. And now we need to figure out our magic number, which we're just going to look at this number. We're going to divide that number by 2 and then square it. So 5 over 2 does not come out to be pretty, so we're just going to square that. So we have 25 over 4. So that's the number we're going to add in order to make a perfect square. So what we've got now, we've got x squared plus 5x. We're going to add 25 over 4. But since we added this random number, we're going to have to subtract 25 over 4 as well so that we don't change the problem. So we had parentheses here, but there's nothing on the outside, so we can move our parentheses like this, and we should be good to go. So now from here, we can factor this guy. So that's going to be x plus 5 over 2, because it's half of 5, squared. And then we're just going to bring that minus 25 over 4 down. And there we go, we've got it in vertex form. So from there we can say, oh, our vertex is negative 5 over 2, negative 25 over 4. And once we find that vertex, it's going to look like a kind of a normal sized parabola going up. Okay, so what does this look like? All things put together, including the graphing part of it. So let's do that. So I'm at number 11, and we're going to convert to vertex form, and then we're going to graph from that vertex form. So we will do the completing the square process first. So we're going to group these two together. So then our magic number is going to be 12 divided by 2, which is 6, and then 6 squared. So 12 divided by 2 squared. So that's going to be 36. Yeah. So that's what we're going to add to both sides, or I'm sorry, to the equation. So now we've got x squared minus 12x. And then here we're going to add our 36, but because we added 36, we need to subtract 36 as well. Okay, so we added the 36, and then we subtracted the 36, and of course we cannot forget about our 39. Okay, so now we're going to group all of these together, and then when we factor that, that's just going to be x minus 6 squared, and then we'll combine the negative 36 and 39. That's going to be positive 3 plus 3. So that is our vertex form. So from there, we can look at our vertex. We got our vertex at 6, 3. 6, 3. And then from 6, we can do 7 and 8, and then 5, 4. And so then we're going to get our values. This is the part where you can just use your calculator. And then we can graph from that. 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. And then 5, 4, 1, 2, 3, 4, 4, 7, 1, 2, 3, 4, 5, 6, 7. And so then our graph is just going to look like that up in the top corner. So again, this is how you can switch from standard to vertex form and then graph. Notice how we're still having to throw a little bit of points at it just to make sure. Eventually we will get to the point where we won't have to do that, but for now we are still throwing points at it. So that's the last one I'm going to do for this video. We're going to practice this in class.